Now, what we will do is to prepare our data to be used as an input for our different machine learning models. So first, let's look at our data, which is first the DF train. And as we can see in the DF train, we have a total 19 columns. The training data will be, of course, this is going to be used as training data. However, we'll be using the data from train in cycles. So this from this column all the way until the LPT equivalent bleed, these are going to be our X, as the input of the training data. And the RUL, the remaining useful life, it's going to be our output of data. So the X part is going to be all these columns from the life in cycles until LPT equivalent bleed. And what we're going to predict, which we call it in machine learning usually Y, will be RUL. So this is, of course, the train. How about the test? Now, for test is a little bit, we need to work on it, because look at, if you look at the test, we can see that we have 1,396 columns, but the test data that we received is, this is the test data we received is the actual RUL is this much, 112. For engine 0, for engine 1 is 98, engine 2 96, and so on. So only we have 100 data points. So we need to choose 100 data points in here. So this is the first way of doing it. We just choose the one of these first points, and preferably is going to be the maximum number of cycles in here, so it will be as close as possible to the failure. As we saw before in the data, the engine get deteriorated when it becomes as close as possible to RUL equal remaining useful life of 0. So we need as much as possible the engine to be run more and more cycles. Now, another way to do it is to augment the RUL, this list, to have it, well, basically 1396,000 rows. So we can do both. So we will go for the simple method, which is we just take the maximum in here and we just equal it with this one. So our testing will be the maximum row of every engine, the maximum row that has the maximum life of every engine, and is going to take from times in cycle up to LPT equivalent bleed as an input, and the Y of the testing Y will be the DF test RUL itself. So we can understand that now we have to mainly work on the DF test, and after that we just gonna continue to prepare the model. We start by doing the same as we did before, in which we take or we detect where do we have the highest, the maximum number of engines. So we do here, we start by DF test and cycle equals DF test, and here we again group by, and we go by engine, and we aggregate this thing into the time in cycles. This one, this a little bit go down here, in cycles to be the maximum number, max. So this one, and we need also, once we have done this, of course we don't want this to be the same name as times in cycle. We rename it, so just we can show this thing. Let's show it. So now we have the engine is time in cycle, and these are the maximum number, the most advanced cycle we have for every engine. So what we will do is we take this one, and we don't want it to be times in cycle because we will add this to our DF train data. So we need to rename it, and the column will be renamed are the times time in cycle and life. We call it the same as we did before, and in place equals true. So here we can see now it just got renamed again, like life engine cycle. And after we do that, we have to merge it again as we did df test, and this one only the max in df underscore test dot merge. Of course, this is a left side merge, so the merge based on our df test cycle df test merge df test underscore cycle, this name, and how left on. So we merge it on, of course, the engine and merge. Oh, sorry. So after the merge, what we are going to do is we need to take the maximum the maximum engine life in cycle, which should equal the engine life itself. So the df test max will equals again df test max, but this time only take the data in which df test max of times in cycle should equal the df test max of engine life itself, life, and we run it. Equals, yep. And now we can see that this row, it become now only 100 rows because it only took the when the life is equal to the cycle. So now we don't need to we need to drop the final one from our df test max. So df test max, what we will do is df test max dot drop when life axis equals 1 in place equals true in place. Yep. We run it again and we are pretty much ready. So we have 100 rows, 18 columns, and we are ready to use this one as an input. Now, just what is left is we assign these variables. So x train equals df train dot iloc, and this is going to extract. iloc is going to look into our data and extract what we need from this data. So this means iLocation based on these I values. We will take the whole rows, these semicolon, or not semicolons, these 2 points is going to be the whole points, and the x going to be from, as we said before, from time in cycle here. Now this is the test, this is the trend, from time in cycle all the way up to LPT bleed, but we don't want to take RUL because we will use it as the y-axis or the y train. So x train, this one, just make sure it's capital letter, x train from 1 to -1, and y train equals, again, the same thing, but this time we don't take except -1, only RUL, the remaining useful life. Now for x test, what we need to do is, again, we go to this one, what we already defined, and we, of course, we take all the rows again, and here we just don't take the engine number, and we will take all of them until LPT coolant bleed. So from 1 to basically everything, everything. Now the last one is y test, and y test we already have it. That is what came with this was TF-RUL, and this time we only need to take the last column. We don't want the engine. So here we are pretty much ready. We run this one. So here we have the x test equals x test max. We didn't have iloc. It's important, of course. Yeah, now we're ready. So we just a quick look, x train, times in cycle up to engine LPT. Y train is the same. Y train is the remaining useful life only. X test going to be also everything. We have 100 rows until the LPT coolant bleed. Y test is going to be RUL only. The same thing with 100 lines, of course, from 0 to 99. And this is it. Now, first, let's, this is X train, Y train. Okay, we're ready. Now, let's just print this one. You understand now it is a data frame. Now, what we need to do is we don't want a data frame. We need a NumPy array. For that, we will add, we need to use sklearn, one of sklearn libraries, in which what we will do is from sklearn dot pre-processing, we need to import min max scalar. So again, usually in machine learning, the data we use is all of it is normalized to make the model is more rigid. So we will normalize our data in which all the values is between 0 and 1 or 0 and -1. And so this is going to be used using this min-max scaler. Of course, you can do it yourself. Now, you can import it. Like for me, I prefer to import everything on the top of the program and re-import everything like this. Sklearn. But of course, you can import it any place you want. Now, finally, what we will do is we pass these to the to our program, to our X training and X test data for to normalize them. So so first we have to call this function. And then we pass on this. So X underscore train equals this one, and fit transform, we call this method. And for, of course, X train, we do the same thing for Y train, and we run it. Sorry, X test, sorry, X not X test, not Y. Y is already, we need it as a value. X test. Yeah. Now you want to see this, how our data become a little bit. This will be a big one. Let's take this one. Print X test, or just you can also do the same. So what you can see is the whole thing X train. So X train or X test, they become actually a normalized value from 0 to like the value cannot increase from 0 to 1. And of course we can the same thing in that the X train as well is all got normalized, and now as you can see it is NP array.